Hello everyone, I'm Terence. Today I'm representing Chemical and Biological Engineering, CBE, and I'd like to introduce you a new program, which is having our program as a backbone and plus AI. In particular, there are two main streams. They are like bioengineering plus AI and chemical engineering plus AI. So what we can do with bioengineering with AI, one of the example is cancer patients with big data. So cancer is a family of diseases and they can evolve from time to time, as you can see here. So in order to predict in the future what type of cancer at which stage they will end up at, we need to study a lot of data, tracing the history and different group of people. At the end, we can develop or have a very high hope that we can have individualized therapeutic recommendations. So one of our colleagues, Professor Terence WONG, has already demonstrated they can successfully diagnose and treat cancer patients by developing computational method of biomedical data analytics. One of their very recent study discovered a targetable mutation in brain cancer, and the work has been covered in many high-profile journals. And another example is by the integration of cutting-edge medical imaging modalities, again with big data. So in the old days, for example, a cancer excision surgery in order to remove the cancers or tumor, and it involves a very lengthy process called frozen section and also pathologist diagnosis. The whole process can go up to 30 minutes and check for any remaining cancers during the operations. And a one-week test, which is a post-operative pathologic assessment, will be even more lengthy. However, it's much more accurate. So if there is a discrepancy between the two, that means there are some cancers being detected after during the one-week test, there will be a call for second surgeries. So this is a very lengthy process. The patient have to come back for resurgeries, could be after a week. So we have developed a new technologies called CHEM microscope, and we envision that the surgeon can cut the tissue out, put it in the CHEM microscope, and very accurate and high quality images can be sent to pathologists in a very short time. And in the future, we hope that the whole process can be done within 3 minutes instead of 30 minutes or instead of 1 week. In the future, with also the big data technologies or artificial intelligence, the pathologist can also be helped or assisted by AI to read all those images, and such that the whole process can be even more accurate and also more efficient. So we obviously can see that it provides better healthcare from 30 minutes to 3 minutes intraoperatively, and also the testing accuracies. The low accuracies of frozen section is around 65%, and this CHEM microscope allows you to go up to 95%. So we can say no to a few different things. For example, the lengthy preparation process, inaccurate test results, and also say no to resurgeries. Finally, for chemical engineering plus AI, you can use it to predict some molecular properties by learning enough molecules, structures, and also the projected antibacterial behavior. You can also use it to design and also make it. I mean, you can design the synthesis of the small molecules using computers, and also at the end, you can use robotics to execute the synthesized recipe. So very powerful technique. And because of the computational power, you can also use it to replace some very expensive computational power and replace some very lengthy simulations. So hope that gives you a holistic and also a very brief overview of how chemical engineering and bioengineering can be integrated with AI. Thank you.